In this video, we will see how the controller is organized. This would be a relatively long video. There are two considerations that come into play when we create the controller. One is that there is a graphical user interface, and the technology to draw that, to create that, would change as time changes. So what we need to do is isolate what could change. This is a common, or this is an important object-oriented design technique. That is, if something could change, let's try to isolate it to a class or a bunch of methods so that when those changes occur, we know where to change. So the organization of the drawing program would be like this. There is a graphical user interface through which the user interacts with the program. So all the input comes into the GUI, and the output also appears on the GUI. So the user deals with the GUI. The user inputs commands, clicks, etc. to the GUI and sees the shapes on the GUI. Then, as we know, there is going to be a controller and a view. The controller would receive the inputs that are given to the GUI in a more logical fashion, in the sense it is less dependent on the technology. So if the user clicks on a button to draw a polygon, the request will come to the controller as to create a polygon. It wouldn't come as a button click or any such thing. It would be a simple event that would end up in a method call to the controller. Similarly, when a mouse is clicked to indicate a vertex of a polygon, we don't really consider it as a mouse click at the level of the controller. We simply say a point has been specified. So we get the two coordinates, the X and Y coordinates of the point. And then using those inputs, the controller will create lines, polygons, etc., etc. And there would be logic to create all these objects, store them, and so on. So the model would be in this part of the system. And as we create shapes, modify them, etc., the view will get to know them and select those shapes for drawing. But ultimately, the drawing has to be done by the graphical user interface. So the view would know what to draw, which shapes to draw, where their vertices, etc. are, and it would actually perform a good part of the drawing logic, but the exact drawing has to take place at the graphical user interface level. So the controller, this logic here, and the view, these three boxes represent code that is less volatile or less transient, less or actually more stable in some sense. The graphical user interface would contain stuff that might change over time. So we are isolating things that could change. A second consideration in the creation of the controller is that we should support undo and redo. We all know what undo and redo are. So the technique for doing undo and redo in object-oriented systems is to keep commands as objects. For example, when we create a polygon, we click on the polygon button object, draw polygon button object, and then we specify all the vertices one after the other and specify that the polygon drawing process is over. All these actions are together stored as an object. That is called a command object, and we have a command pattern. In a command pattern, we have an abstract class, or perhaps even an interface. We'll have an abstract class with 3 methods: undo, redo, and execute. When a command is created, it can be executed so that the command is in place. For example, drawing a polygon, it gets carried out. When we need to undo that, we will call the undo method. The command will know how to undo it. And if we need to redo it, we will call the redo method. So every command in the drawing program, like drawing a polygon or drawing a line, they would have a corresponding command object. And here is how commands are carried out, or rather undo and redo are carried out. We maintain a stack called the history stack. It contains all the command objects. For example, if we have a bunch of commands, a label object, a circle object, another label object, a line object, they are placed on top of each other on a stack. So this is the most recent command at the top, which is a line object. And the previous command was to create a label. The one before that was to create a circle. And the first command was to create a label. So we have a stack of command objects. The redo stack at that point is empty. The model would contain, corresponding to each of these commands, one object. Line object, there will be a corresponding object in the model. The label object, label 2, it is here in the model. Circle object, there will be a circle object here. Label command, there will be a label object here. Now suppose we undo the last action, which is the line. So the command is at the top of this stack. It will be popped and put in the redo stack. The line object would be removed from the model, so the view will not display the line object anymore. So the redo stack contains the undone commands, and the history stack contains commands that have been carried out and could possibly be undone. So we are going to have an abstract class called command, which will have 3 methods: undo, redo, and execute. The individual commands would know how to execute the command, how to undo the command, how to redo the command. That depends upon the command object. It depends upon whether it is a line or a polygon or a circle or something else. To manage undos and redos, what we are going to have is a class called undo manager, which is a singleton. It will have, as we saw in the previous diagram, a history stack and a redo stack. And these are stacks containing commands, as we have seen. When we have a new command, the controller will have this method invoked. Actually, the undo manager is part of the controller. The controller class or some class will call this begin command, and the redo stack will be cleared, and then we push the command onto the history stack. So that will be at the very top. The redo stack clearing is very useful, otherwise we might get into inconsistencies. You can read this in the reading about why the redo stack clearing is helpful or even essential in places. And when we finish the command, we simply update the view. So these are methods in the undo manager: begin command, end command. Also, we have the undo method in the undo manager. When the user clicks on the undo button, this method gets called. The undo method in undo manager gets called. What it does is it checks whether there is anything to undo. If there is nothing to undo, there is nothing to be done. If the history stack is not empty, it will undo the command at the top and pop it out of the history stack and push that onto the redo stack. This we saw in the diagram, right? The very top object. This was popped and pushed onto the redo stack, and that would be undone. So the corresponding line object was removed from the collection that is stored in the model. And here is redo. If the user clicks redo, we see whether there is anything in the redo stack. If something was undone, and if it is in the redo stack, we pop the redo stack and redo that operation. The command will know how to redo it and push the command onto the undo stack. So that is now eligible for undoing. When the user clicks on something in the GUI or presses or types in a character or whatever, all those requests come to the controller class. So the controller class gets requests from the graphical user interface. The graphical user interface calls specific methods of the controller, like when a label is to be created, it calls on label command. When a line is to be created, it calls this method on line command or on polygon command, and so on and so forth. So the controller class has all these methods. It keeps track of the current command, and this is null if there is no shape being created or no command is in progress. The command could be to retrieve data, to save data. Okay. So if the label command is issued, controller checks if current command is equal to null. If nothing else is in progress, it remembers that the current command is now a new label command, which is created here. So label command is a subclass of command. It is capable of remembering a label. It knows how to construct a label, and so on and so forth. Similarly, there is a line command and a polygon command. If you can write one of these, writing the others is not all that difficult at all. It is the same pattern. If the current command is null, if there is nothing else going on, if there is no other shape being drawn, for example, we can allow this new shape to be drawn. And we remember that in set command. All set command does is it sets current command to this command. Then, of course, there are other kinds of things that the controller will get. For example, when the mouse enters the drawing panel, we need to tell the view to change the cursor, or when the controller leaves the drawing panel, the view should change the cursor to default. And here is another set of methods. When a character is typed, we get the character as a string. So this method gets called from the graphical user interface. And if there is a command in progress, that command should know what to do with this character. For example, if it is a label that is being constructed, that label command would know what to do with that character. If it is going to be a line command, we will still send it to the line command, which will probably ignore that. Similarly here, what should be done when the backspace key is pressed? The graphical user interface knows when the backspace key is pressed, it senses that using the technology related API and calls the on backspace method. And if a command is in progress, the command is told that backspace key has been pressed. Again, the label command would do something, could do something on a backspace, but for a line command or a polygon command, this doesn't make much sense. Similarly here, we have on point input. That is when a mouse is clicked, we store that information in a point object. Actually, we create a custom class called canvas point so that we don't have any technology related classes in the controller. We have this canvas point that would be created by the graphical user interface, and the current command is told that a point has been specified. It would make sense to the label command. It would mean that there is a new label being created. It could specify a vertex of a line or a vertex of a polygon. So the current command is told that a point has been specified. Similarly, when the cursor is moved, we tell the current command that the cursor has been moved. We have even more methods here. When the user wants to abandon the current command, the user would press the escape key. That actually comes to the graphical user interface. The graphical user interface would sense the pressing of the escape key and call on abandon request. And if the current command is not equal to null, it will be told to abandon the current command. So it will be deleting the command object from the stack and so on and so forth. And here are the methods to open and save drawings. So if you want to open an existing drawing, if you want to retrieve that drawing, you specify the file. The user specifies the file through the graphical user interface and sends the file object. The graphical user interface would pick out the file object corresponding to the saved drawing and sends it to the controller as a parameter. And if there is no other command in progress, it creates an open command object and passes the file. It would carry out all the steps needed for retrieving the drawing. And we set the current command to null in command ended, and we update the view. Similarly, save request. The user would specify the file into which the drawing should be saved. And if there is nothing going on, if there is no shape being drawn, we create a save command object, which will actually save the drawing. And we set current command to null in the command ended method.